Welcome to the Web Developer Roadmap of 2024. This video is for those who already have their first developer job but are looking to advance their position or get hired by a new company. If you don't have a developer job yet and you're just getting started, then you need to check out the first part of this roadmap, which will be linked down below. So assuming you've landed your first job as a web developer, you will now be granted access to several workspace tools. If you're a bit more experienced, you might think, why even talk about this? It's obvious how to use Slack or Jira, but I remember when I first got hired by a company and they added me to their tools, like Slack for example, I didn't know anything about Slack, like what it is and why people use it. So if you also felt the same, then this part is for you. In any development job, you'll be granted access to several workspace tools that are mostly used for collaboration, project management, and communication for the team. Jira, for example, is the project management tool designed for teams. You will use it to track issues and tasks throughout the project, like who's working on which tasks or bug. And you'll notice that there are different types of work items in Jira board, such as tasks, bugs, stories, or epics. And it can be confusing if you have never worked with them before. So let's see what each of them means. A task represents a unit of work that needs to be done. For instance, this can be updating login page UI or something like that. Bugs, on the other hand, are issues that indicate something is not working as expected. For example, if users cannot reset password on the login page, then this will be considered as bug in Jira. A story or user story is a feature that is described from the perspective of the end user or customer. An example of a user story can be, let's say as a user, I want to filter search results by date so that I can find the most relevant articles. And since stories are usually tasks that require high effort, the development teams rate these stories with story points. The story points are numbers of the Fibonacci sequence, and the number specifies the difficulty of this story. Then we have also epics, which represents a big feature or goal that combines multiple of these stories. You'll also notice that your team is likely using some sort of agile or scrum methodology, which divide the development process into short periods, typically 2 weeks, where a set of stories and tasks are selected to work on. And these 2-week periods are called sprints. The next tool is Confluence, which is used for project documentation. It helps teams to create, share, and collaborate projects in one place. For example, you can see the onboarding notes in Confluence, or some documentation of the feature, or even the architectural diagrams and documentations of the application. And with Scrum methodology, you will also have daily calls, bi-weekly sprint plannings, and other meetings. And these meetings will be held in some sort of meeting softwares like Microsoft Teams, Zoom, Google Meet, and so on. Then we have Slack, which is a messaging app, just like Messenger or WhatsApp, but it is more focused on group chats for teams, which are called channels, and they represent the same concept as group chats, except that most of the channels are public for everyone to access. The next area you'll dip into is CI/CD pipelines, which stands for continuous integration and continuous deployment. This includes several things. The first one is environments. This part was also confusing for me at the beginning, like the dev environment, staging environment, or production environment. What are these that everyone keeps talking about in the Slack channels? And luckily, this is a very simple concept. Teams usually create 2 to 3 different environments, depending on the size of the team and the project. Like a development environment, which is used by developers to test their changes, or staging environment, also called test, for QA testers to test the changes and verify that it works properly, and production environment, which is the real application or website that its users use. Another part of CI/CD is the deployments. If the CI/CD is set up properly, then this is an easy task. You just run a certain GitHub action or Jenkins action, and it starts the deployment of your code to the environment you specify. GitHub Actions and Jenkins are tools you'll use to automate your CI/CD pipeline. And every pull request that you open or deployment that you trigger goes through a series of pipeline checks to verify that everything is fine before deployment. For example, it runs the tests. These can be unit integration tests or end-to-end tests, checks the linter, and then starts to do the deployment. If any of these pipelines fail, it stops the process, and if it went successful, it deploys your code and typically notifies you in a Slack channel. And this code that we deploy has to usually end up somewhere, and that is where we get to the hosting. This is where your web application is deployed after you run the GitHub or Jenkins actions of the deployment. The most popular providers nowadays are AWS, Azure, and Google Cloud Provider. They provide different services for hosting web apps, their backend services, and even serverless cloud functions all in one place with a cost-effective method, which is to pay as much as you use the resources, instead of the traditional fixed server costs, and they also handle the scaling of the system, which can be cost-effective for companies, because they don't have to keep the large DevOps teams to handle the infrastructure. For simpler sites or web apps, there are static and managed hosting services that provide a more straightforward serverless solution to deploy your projects quickly. These can be used for small projects or even for your hobby projects. If you are just looking to deploy your web app somewhere, then you'll likely use static and managed hosting services. And as you move further to the backend domain, it becomes essential to understand the infrastructure that supports your application. But before moving on to the backend languages, let's first talk about web servers, which are the systems that deliver content to end users over the internet. Using HTTP and other protocols, it accepts requests from clients, usually web browsers, and responds by serving web pages and other types of content like images, video, and data. The common engines that are used in web servers are Nginx or Apache. These help us handling client requests and serving the right content. Nginx, for example, is known for its high performance and stability, and it can also act as a reverse proxy or an email proxy. And the most popular reverse proxy example is load balancers that distribute network or application traffic across a number of servers, and this ensures that no single server bears too much demand, and it improves the responsiveness and availability of these applications. Then we have also CDN web servers, which are networks of servers that deliver cached static content from websites to users based on their geographic locations. This gives us the advantage of faster delivery and less stress on any one server. You will learn why CDNs are essential for reducing latency and speeding up the delivery of resources by serving them from locations closer to the end user. And these web server concepts will start to make more sense after you learn one backend language and begin to work with APIs. Therefore, the next logical thing is to learn a backend language. The web app's backend is where your application's logic runs and data is processed. And there are different backend languages to choose from, like Java, for example, which is a versatile object-oriented language that is used in large-scale enterprise environments, especially good for big data processing. We also have C#, which is developed by Microsoft, and it's primarily used with ASP.NET Framework for web applications. Then we have PHP, which is easy to learn and widely used for web development. Currently, it powers popular content management systems like WordPress and Shopify. Ruby is known for its elegant syntax. It is often associated with the Rails framework, which emphasizes the convention over configuration, and it's used for rapid web development. Python is another super readable and efficient language, and it's popular in data analysis, artificial intelligence, and scientific computing. My recommendation is to start with the Node.js. It's a JavaScript runtime built on Chrome's V8 engine, and it allows you to write server-side code using JavaScript, which you're already familiar with from front-end development. And this means you can use a single language across your entire stack, and later you can learn some of these other languages if you'll need them in a project, but this is the easiest one and also a popular one. Let's break down the most common concepts in Node.js that you'll need to learn. You'll need to learn about Node.js architecture. It's an event-driven architecture, and it features a non-blocking I/O model, which makes it lightweight and efficient for real-time applications. Node.js also uses event loop as JavaScript, although it's a bit different than the browser-side event loop, but it's mostly similar, and you'll understand this very quickly if you know JavaScript well. The event loop is what allows Node.js to prevent non-blocking operations despite being single-threaded. Then we have the core Node.js modules. Modules like fs for file system operations, or path for path operations, or HTTP for server creation, and other core modules are the building blocks of the Node.js app. Another common concept in Node.js are middlewares. They are just functions that have access to the request and response objects, and they can modify them or execute any code. For example, features like authentication are implemented here through middlewares. Then we have streams and buffers that allow us to process big data like videos or images in small chunks. And after learning the fundamentals, you'll need to pick a framework to work with, because it's very unlikely that you will write a real backend API with pure Node.js. Here, Express.js is the most popular one, known for its simplicity and minimalism. Nest.js is inspired by Angular and provides an out-of-the-box application architecture. And Happy is a rich framework for building applications and services. These are just few of the frameworks. These are the most popular ones, but there are more frameworks to choose from. So after getting comfortable with a backend language, you'll start building APIs. The most common type of API is the REST APIs. This is an architectural style that uses HTTP requests to access and use data. They are typically used to perform standard database functions like reading, creating, updating, and deleting records within a resource. GraphQL is probably the second most popular type of API. This is a query language for your API and a server-side runtime for executing queries by using a system you define for your data. GraphQL isn't tied to any specific database or storage engine, and instead is backed by your existing code and data. gRPC is a high-performance RPC framework that uses HTTP2 for transport, and it uses protocol buffers as the interface description language. gRPC is primarily designed for server-to-server communication, but for server-to-client communication, you will probably use GraphQL or REST API. Then we have the protocols that are used by these APIs for communication. HTTP is the standard protocol of data communication for the web. You are already familiar with it from the front-end part, but backend development involves deeper aspects of this protocol. WebSockets are used for two-way communication channels over a single TCP connection, and because of that, mostly it's used for real-time data transfer between the client and the server, like for chat apps or for video streamings and things that require real-time data processing. SSH or Secure Shell is another protocol which is used for secure remote login over a network. For example, you might use SSH to log into your remote web server for troubleshooting or performing maintenance operations, or in situations where CI/CD pipelines are not enough and manual intervention is necessary. Security is another important aspect of APIs. Here you'll learn about hashing, which is used to securely store passwords and other sensitive data, or encrypting, which is for transforming data into a secure format that another unauthorized parties cannot access without a key. And the party that has this key can securely decrypt that data and read it. We also have signing, which ensures the authenticity of data by providing a digital signature, and encoding, which converts data into a different form, often to prepare for transport or storage. Another popular tool is Docker that wraps your API into an isolated environment, which is called container. And this makes sure that if the API is running on your local machine, it will also smoothly run on the remote server and will reduce the issues of having different operating environments. Lastly, we have serverless, which is a cloud computing execution model where the cloud provider like Google Cloud or AWS runs the server and dynamically manages the allocation of machine resources. With serverless, the cloud provider dynamically manages the allocation and provisioning of servers and automatically scales the application without you worrying about the underlying infrastructure. So after getting familiar with APIs, the next important part of backend server is how you authenticate the users. The most common type is token authentication, which is a stateless method where the user is authenticated via tokens, and this can be further divided into access and refresh tokens. Access tokens are used to make authenticated HTTP requests, and refresh tokens are used to obtain new access tokens without having to authenticate again. Then we have GWTs, JSON Web Tokens, which are compact tokens representing claims to be transferred between two parties, allowing for secure information exchange. The traditional authentication method is with cookies and sessions. Traditionally, sessions are managed using cookies, which are sent with each HTTP request, allowing the server to identify users across requests. Then we have the OAuth, which is an open standard for access delegation. It uses a way for users to grant websites or applications access to their information on the other website, but without giving them the passwords. So authentication is the process of verifying who a user is, but authorization, on the other hand, is the process of verifying what they have access to. For example, a user can be an admin or just a user, or they can be super admin, and there are different roles, and these roles are controlled by authorization methods. Then we have also managed authentication. This is where the third-party services like Amazon Cognito, Firebase manage the user authentication and authorization for your applications. They offer a secure way to handle these user sign-up, sign-in, and access controls, and provide additional features like social login and multi-factor authentications. So this is an easier way to implement the authentication, and it's also secure and probably a better option for small teams instead of implementing an authentication yourself. So that's the authentication part of the web APIs. Then you'll also need to learn about databases and different database types. The most common ones across web APIs are SQL and NoSQL databases. SQL databases are also known as relational databases. They use structured query language (SQL) for defining and manipulating their data. And SQL databases are based on schema that defines the structure of the data. Some of the popular SQL databases are PostgreSQL, MySQL, SQLite, OracleDB, and there are some more, but these are the most popular ones. Then we have the NoSQL databases. These are non-relational and they can store and process a large amount of unstructured data. They offer more flexibility and scalability compared to traditional SQL databases. MongoDB, for example, is a document database that stores data in flexible JSON-like documents, meaning the data structure can be changed over time. And Redis is an in-memory key-value store known for its speed and often used for caching because it's in RAM and it's very fast to access. We also have graph and vector databases. These are used typically in very specific cases because they are specialized databases optimized for queries that involve traversing relationships like social networks or recommendation engines. After learning and practicing the topics we've covered here, you are now well equipped to take the next step in your career. You can either climb the ranks within your current company and ask for promotion, or apply for a new role to get yourself a better position and salary. From my experience, it's better to change your project every 1 to 2 years, because first, this will help you grow faster as you work on different type of projects, and second, you usually get a bigger salary increase than if you got promoted in your current company. In our next video, we'll continue the path from where you stand now to reaching the senior developer position, and we'll cover the advanced skills you need to learn to get there. Don't forget to subscribe and see you in the next video.